This video is going to have a look at electrolysis. In lessons you should have seen and had a go at the practical for electrolysis, so I'm going to recover that, say exactly what electrolysis is, and then talk about the products of different types of electrolysis. So the first thing you need to know is that electrolysis is the splitting up of a compound using electricity. So any compound can be broken up using electricity as long as it's in a molten state, which means it's a liquid. So this is the basic diagram that you should be familiar with. Here we have our power supply, and it is direct current. What that means is the current going to each of the terminals is constantly either negative or positive. If you use alternating current, it means that the current goes up or down from positive to negative all the time, which makes it very difficult to collect the products. So in the exam you need to make sure you say direct current. So what happens is they'll put a liquid in here. Now that liquid can be hydrochloric acid, it can be water, it could be salt water, and then it splits it up into the basic compounds. So for example, if we start off with hydrochloric acid, HCl, what happens is it then breaks up, when it's in a liquid, into its different elements. So you get hydrogen and you get chlorine. The pluses and the negatives you don't need to worry about this year, that's something you'll learn about when you do the additional course. So your positive hydrogens go to this electrode and your negative chlorines go to this electrode. If you did want to know what the electrodes were called, the positive one is called the anode and the negative one is the cathode. So once these elements with electricity being passed through them go to this electrode, it turns them back into their normal gases. So chlorine, it turns back into Cl2 because it's diatomic, and this raises up, which is why you see bubbles. And then hydrogen becomes H2 and that also rises up. So in an exam it might easily ask you to turn around and say, what are the products of electrolysis of hydrochloric acid and how can you prove it? So remember that the test for chlorine is you put damp blue litmus paper, which then goes red and bleaches, and hydrogen, you put it into a test tube, you get a lit splint, pop it in, and if you get a squeaky pop, hydrogen is present. And just remember, it has to be molten. So if we've got just a rock with a metal in that we wanted to break apart, if you put the electrodes in there, nothing will happen because the elements themselves can't move about. So nothing will happen. So if you then melt it, turn it into molten, those little ions, the atoms, are free to move, therefore electrolysis can occur and you can split it up. So there are three different ones that you need to know. We've just done hydrochloric acid, which splits into hydrogen and chlorine. You've got water, H2O, which splits into hydrogen and oxygen. And again, they could ask you what the test is for both of these. Hydrogen, squeaky pop test, and oxygen relights a glowing splint. They might also ask you how to collect these gases. So that's nice and simple. You have a test tube above the electrode, and then the gas will just collect above it. The final one is sodium chloride in water. So if we have a beaker that's got water in, and then you add in salt, what happens here is it breaks down into the four different elements as soon as you put your electrodes in. So in here you have sodium and chlorine, and you have hydrogen and oxygen. Again, don't worry about the charges that I've put on there. Now what happens straight away is something called sodium hydroxide forms. So in this solution here you get NaOH, which is sodium hydroxide. So that leaves you with chlorine and a little bit of hydrogen left. So hydrogen will go to the negative and you'll get hydrogen gas coming off here, and chlorine will go to the positive and you get chlorine gas coming off here. And the way to test that this is sodium hydroxide is to put some universal indicator solution in. If it goes a purple colour, then you know you've got your sodium hydroxide in there. If it's just salt water, it will stay neutral. So remember that sodium chloride and water gives you chlorine and hydrogen gas off, and you're left with sodium hydroxide in the solution.